Section 8.5 is slope-intercept form. I can graph linear equations in slope-intercept form. We're going to look at the graphs in the top of page 412 here. This is the graph of the equation y equals 2x plus 3. We can see the graph's y-intercept is at 3, and the line slope is 2. Notice that the slope is equal to the coefficient of x here in our equation, the 2, and that the y-intercept is our constant term in the equation. This is always true for an equation written in slope-intercept form. We called this form before function form, where it's y equals. Same idea here, slope-intercept form. So in slope-intercept form, we always have y equals mx plus b. The number in front is my slope, and my coefficient after the fact is my y-intercept, or my b value. So slope-intercept form, a linear equation of the form y equals mx plus b is said to be in slope-intercept form. The slope is m, and the y-intercept is b. In example 1, we're going to identify the slope and intercept of the line with the given equation. So here, remember that the number in front of x, if there isn't one, is always a 1. 1 times x. My slope and my y-intercept are what we're looking for here. Remember, our equation is y equals mx plus b. M is our slope. B is our y-intercept. So here, my slope is the 1. My y-intercept, don't forget to take the sign in front of the number with the number, -4. In b, we have to solve for y first. So here, my first step to get y by itself is to move the 3x from one side to the other. In order to get rid of a positive 3x, we have to subtract 3x. Keep in mind that the 3x has an x, the 10 doesn't, so we can't combine them. I'm going to put my variable term first, minus 3x, the sign stays with the number. My 10 is positive, so plus 10. Now I'm still trying to get my y by itself. So I'm going to divide by 5 on all the pieces. It's being multiplied, we get rid of multiplication with division. So y equals -3 over 5 times x plus 2. Again, y equals mx plus b. So my coefficient, or the number in front of my x, is my slope, -3/5. The number afterwards, my constant term, the one without a variable, is my y-intercept. In example 2 here, we're going to graph our equation. So when we have an equation that's written in function form or slope-intercept form, we can pull out our slope and our intercept and graph fairly quickly from there. So my slope, again, is my coefficient, the number in front of my x, -2/3. My y-intercept is my constant. It's the one without my variable. And we've talked about intercepts before. Intercepts are where it crosses the graph at that axis. So my y-intercept is 4. So I go up to 4. That's my first point. Y equals mx plus b. B is where we begin, and m is the direction to move. So we're going to begin at our y-intercept at 4. And then I'm going to use my slope. Remember, slope is rise over run. And I'm going to use that to find some more points. So I'm going to rise a -2, which actually means I go down 2. And I run 3. And this right here is my point. I go down 2 over 3. I can connect those points with a line. I always make sure to do it at least twice if I can fit it on my graph, just to make sure that I counted it right. And then connect them with our straight edge. Go all the way through our points, and we put an arrow to show that it continues. So again, our b value, our y-intercept, is where we begin. and our m is our slope. It's how we move. So from our first point, here since it was negative, I go down to right 3, and we always move from left to right, just like when we read a book. Read a graph the same way. Feel free to pause here and give these a try if you'd like. We're going to go ahead and find the slope and y-intercept, and then graph the equation using those values. So in number 1, remember the number in front of an x, if there isn't one, is always a 1. So my slope is that coefficient, that number in front of my x. Here it's -1. My y-intercept is my constant after the fact, a +1. Now for slope, we always want to have a rise over run. So whole numbers I write as over 1 to get a fraction. Okay, 4 is 4 over 1. -6 is -6 over 1. -1 is -1 over 1. So here we are going to start at our intercept. B is where we begin. B is where we begin. And that's my y-intercept. My slope is -1 over 1. So I'm going to go down 1 over 1. Down for a negative rise, run. And continue our pattern. We can then connect the dots with a line. Make sure we extend it. And use arrows to show it continues. Number 2 here is not in function form. It's not in slope-intercept form. So we need to solve for y first. Again, looking for y. So the first thing I'm going to do is get rid of my 3x. Right now it's a +3x, so we subtract to move it to the other side. Don't forget that we have a -2y. We bring the sign with the number. Our x goes first, and it's a +6, so +6. Now, to get our y by itself, I'm going to divide by -2. It's being multiplied. We get rid of multiplication by division, and we do that to every term. So -3 divided by -2 gives me +3 over 2. 2 negatives make a positive. 6 divided by -2 gives me a -3. So here, my y-intercept is my constant, my -3, and that's going to be where I begin, my first point. My slope is 3 over 2, which is my rise over my run. So I'm going to rise 3, run 2. Rise, a +3 means I go up over 2. We go towards bigger numbers, towards the positive numbers, over 2. And then I connect the dots. Make sure all of our points line up. If they don't, it means you probably counted your slope wrong. So you want to double check there. And that's why I always make sure to do at least 3 points. And number 3 here, keep in mind that if we don't have anything added, we can add a 0. 4x is the exact same thing as 4x plus 0. So here, my y-intercept is 0. That's where I begin. My b value is where I begin. Begin. My slope is 4, and that's the direction we move. And again, with whole numbers, we can write that slope as over 1 with our integers or whole numbers. So I started at 0. My slope is up 4 over 1. So I'm going to go up 4 over 1. I'm going to go up 4 over 1. And that's off my graph. So I want another point on my graph just to make sure that it all fits. So another way that I can get to 4 is by taking -4 over -1. I can make them both opposites because a negative divided by negative also gives me a positive. So here, I can go down 4 Okay, -4 towards the negative numbers, and -1 towards the negative numbers. Back 1. Down 4, back 1. I can go down 4, back 1. And we only go to the left if we're going backwards. So we do the opposite of the top, opposite of the bottom. So instead of positive, positive, we made them negative, negative. And that allows me to line up my points just a little bit better. Now we can connect our dots here. And arrows to show that pattern continues. So this is 3. In real-life problems involving a linear equation, the y-intercept is often an initial value, where we begin, and the slope is the rate of change. So the temperature at Earth's crust averages about 20 degrees Celsius. In the crust below the surface, the temperature rises by about 25 degrees Celsius per kilometer of depth. Write an equation that approximates the temperature below Earth's surface as a function of its depth. So temperature depends on depth. We know that it starts at 20. And we know that it rises, which means that's our rate of change, 25 degrees Celsius, so 25 degrees Celsius per kilometer of depth. So our temperature equals 25D plus 20. And T is in degrees Celsius. Underground bacteria exist that can survive temperatures of up to 110 degrees Celsius. Find the maximum depth at which these bacteria can live. So now we want to know for temperatures 110, we're going to plug that in. Make sure it's in degrees Celsius. Perfect. So 110 degrees equals 25D plus 20. I'm going to subtract 20 to solve for D. We're looking for the maximum depth. Divide to get rid of our multiplication, and we get 3.6 equals D. We said D is in terms of kilometers of depth, so 3.6 kilometers is the maximum depth. I'm going to stop here and continue on in another video.